So question number 9. So when you look at this question, we are talking about, the question is actually talking about the derivative, integration, and area. So means this question is derived from the topic 5 of your curriculum. Topic 5 is calculus, right? So we have function f of x equals to 8x over x squared plus 1 to the power of 3. So question A, we need to show that the derivative of the function f of x is same as 8 times 1 minus 5x squared over x squared plus 1 to the power of 4. Okay, so let's do this question in a new page. So we know that f of x is same as 8x over x squared plus 1 to the power of 3, right? So in order to differentiate this function, since this is a fraction, you can use either product rule or quotient rule to solve this, okay? But here I'm going to use the quotient rule to solve this question. So how do we use the quotient rule? So if you have a function y equals u over v, so fraction form, we can find the derivative of this function using the formula y prime is same as u prime times b minus u times b prime over b squared. Okay, so we have function f of x equals 8x over x squared plus 1 to the power of 3, and let numerator equals to u and denominator equals to v. Okay, then u is same as 8x, then u prime is same as 8, and v is same as x squared plus 1 to the power of 3, then b prime is same as 3 times x squared plus 1 to the power of 3 minus 1, and since this is a function inside a function, we need to use the chain rule to differentiate it. So finally we have to multiply the 2x to have a complete equation. So this is same as 6x times x squared plus 1 to the power of 2. Okay, then let's use this combination to solve the derivative of the function f of x. Okay, so we're going to do derivative of the f of x is same as u prime 8 times b x squared plus 1 to the power of 3 minus u 8x times the b prime, which is 6x times x squared plus 1 to the power of 2 over b squared, which is x squared over 1 to the power of 3 to the power of 2. Okay, then the numerator part is same as 8 times x squared plus 1 to the power of 3 minus 48x squared times x squared plus 1 to the power of 2 over x squared plus 1 to the power of 6. Okay, since we have x squared plus 1 to the power of 3, x squared plus 1 to the power of 2, x squared plus 1 to the power of 6, we can simplify this, right? And this becomes 8 times x squared plus 1 to the power of 1 minus 48x squared over x squared plus 1 to the power of 4. Then we have 8x squared plus 8 minus 48 x squared over x squared plus 1 to the power of 4. Then this is same as 8 minus 40 x squared over x squared plus 1 to the power of 4. Then simplifying the numerator will give us the 8 times 1 minus 5 x squared over x squared plus 1 to the power of 4. So we have shown that the derivative of the function f of x is same as 8 times 1 minus 5x squared over x squared plus 1 to the power of 4. So QED. So question B, now we need to integrate the function f of x. So let's do this in a new page. So we know that f of x is equal to 8x over x squared plus 1 to the power of 3. And we are integrating this, so it means we can rewrite this integration, given integration as 8x over x squared plus 1 to the power of 3 times dx. Okay, then let's try to get rid of the fraction. So 8x times x squared plus 1 to the power of negative 3 times dx. Okay, then you can see that this is a function times function, and the other function has another function with inside. Okay, so means we have to use the substitution. Okay, so let's say u equals to x squared plus 1. Okay, then du over dx, when you differentiate the u in terms of x, this will give us the value of the 2x. Then we can say that du is equal to 2x times dx, right? Then let's try to rewrite this equation. We know that 8x times, since now we have said that x squared plus 1 is u, so we can say u to the power of negative 3 is same as dx. Then reorganizing this equation will give us the value of 4 times u to the power of negative 3 times 2x times dx, right? Then we know that 2x times dx is same as du, so means we can also replace this part with du. Okay, and that means we can rewrite the integration as 4 times u to the power of negative 3 times du. Then we can now integrate this equation very simply. Then it will give us the value of 4 times u to the power of negative 3 plus 1 over negative 3 plus 1 plus c. Okay, then this simplifies it as 4 times u to the power of negative 2 over negative 2 plus c, which is same as negative 2 times u to the power of negative 2 plus c. Then we can say that the integration of the function f of x is same as negative 2 times, since the u value is same as x squared plus 1, x squared plus 1 to the power of negative 2 plus c. This is same as integration of the function f of x in terms of dx. Okay, then let's talk about question C. So you can see here that we have more information now, right? So g prime of x is same as f prime of x, and the R is the region enclosed by the graph of f, the graph of g, the line x equals 0 and the line x equals 3, and the area of the R is 27 over 2. So g prime of x equals to f prime of x. This is actually same as g of x is also same as f of x, right? So you can see here we have function f of x graph here, right? We know that the area is enclosed by the x equals 0 and x equals 3. So we can say that, okay, so this is x equals 3 and x equals 3. So we can say this is x equals 0 and this is x equals 3. Then we are not sure where the graph g of x is. We can just assume that graph of g of x is maybe a little bit lower than the f of x, like this. Okay, we can say this as g of x. Then we can approximately set the equation as since f of x is same as 8x over x squared plus 1 to the power of 3, g of x is same as 8x over x squared plus 1 to the power of 3, and since it might have moved up or moved down, we can say that extra k there, so we can identify the location of the g. Okay, then we need to find the two possible expression for the function g of x, right? We know that the equation might look like this, but since we're not sure about the k value, we're going to identify that k using the area information. Okay, so to calculate the area, we already know that the area value is 27 over 2, and to calculate the area between all these values like x equals 0, x equals 3, the graph f, the graph g, we need to use the integration, right? So the range is 0 to 3 since we are using definite integration, and we have to subtract one function from the other. But since we are not sure which one is higher, we can use the absolute to regulate the final answer. Okay, then we do g minus f, which is same as 8x over x squared plus 1 to the power of 3 plus k minus 8x over x squared plus 1 to the power of 3. Okay, then let's try to simplify these three terms by having a common denominator. So 8x over x squared plus 1 to the power of 3 plus k times x squared plus 1 to the power of 3 over x squared plus 1 to the power of 3 minus 8x over x squared plus 1 to the power of 3. And this is same as, we can simplify this part, then this is same as k times x squared plus 1 to the power of 3 over x squared plus 1 to the power of 3. And it can simplify further with k. Okay, so g minus f is same as k. Then we know that area, which is same as 27 over 2, is same as definite integral 0 to 3 k times dx. Okay, then this is same as plus minus kx, and the range is 0 to 3 and is equal to 27 over 2. Then we can say when we have a positive value, 3k minus 0k is same as 27 over 2. Then we can say 3k is equal to 27 over 2, and k value is same as 27 over 2 times 1 over 3, which will give us the value of 9 over 2 when we have a positive values. Then when you have negative values, we have 3k minus 3k minus 0k equals 27 over 2, which is same as negative 3k equals to 27 over 2. K value is same as minus 1 over 3, both sides, right? And this will give us the value of minus 9 over 2. So we can say that the two possible expression for function g of x is same as 8x over x squared plus 1 to the power of 3 plus 9 over 2, or g of x equals to 8x over x squared plus 1 to the power of 3 minus 9 over 2. So we have got two possible expressions for function g of x.